Welcome to another video. Here is a trigonometric equations required to prove that the left hand side equals to the right hand side. Okay, so we are given this side as the left hand side while the other side is the right hand side. So to do this, if you are trying to use the right hand side to prove this, so the question might take us some times. So therefore, I'm going to use the left hand side to prove this. So you might still use the right hand side to prove it, depend on how faster you are able to think. So let's see how to use the left hand side to solve this. So we are given this at the left hand side, so which is 1 plus 2 sine x cos x divided by sine x plus cos x. What I'm going to do here is I'm going to rationalize the denominator by changing the positive sign to negative sign. Then we are going to have sine x minus cos x divided by sine x minus cos x. So that's what I think, that rationalizing this will make this thing work. So that's why I am rationalizing it. So we are going to bracket to avoid confusion of this multiplication with x. Then, so by opening the parentheses, 1 we multiply sine x, then we have sine x. Then 1 we multiply negative cos x, we have negative cos x. So similarly, 2 sine x cos x, we multiply sine x. So since we have 2 sine x, so sine we take square. Then we are going to have 2 sine square x, then cos x. So y for the last one, which is cos appearing 2 times. So that one we take square, y the others will be negative 2 sine x cos x. And we must see that from this denominator, so this is just like the difference of the 2 square. So they are the same but with opposite in sign. Then we just multiply the first with first and the last with last. So hereby we have sine square x and negative cos square x. So at this stage, what I'm going to do here is by collecting the like terms, but there is nothing like terms here. So I'm going to combine sine x and the last terms here together. So while the two middle terms, I'm going to combine them. So just to make this thing reality, here we have sine x minus 2 sine x cos square x, and y for the second one, then we have negative cos x and plus 2 sine square x cos x, and we divide everything by sine square x minus cos square x. So we have it as sine square x minus cos square x. And after the collection of these terms, so we are going to take out this sign, and by taking out sine x, we have this remain 1 minus 2 cos square x, and for the second one we have, by taking out cos x, so this remains 1, but I've taken out negative, so the positive here we change to negative, because when we expand, so we are going to get what we have above. And here we have sine of square x minus cos square x. Okay, so at this stage I'm going to employ some identity. So if you note that from this double angle formula of cos, if you have cos 2x, so this is going to give us 3 different identities. So the first one is 2 cos square x minus 1. I'm going to apply all the 3 in these questions. So this can also be 1 minus 2 sine square x, while the last one is going to be cos square x minus sine square x. So all these things, I'm going to apply it in the last line I stop. Okay, so let's see how to use all these in the above lines. So we have 1 minus 2 cos square x, but what we are given here is 2 cos square x minus 1. So what we are going to do here is by just changing this to negative. So just to make this thing looks like 1 minus 2 cos square x. So it is 2 cos square x minus 1 we are giving. So by just changing the negative sign of by introducing the negative to cos 2x, is going to give us 1 minus 2 cos square x. So and for the second one we have cos x, and this one is perfect. 1 minus 2 sin 2x is one of the identity of cos 2x. Then we just replace it as cos 2x. Okay. Then we are going to have cos 2x instead of 1 minus 2 sin square x, and everything divided by here is sin square x minus cos square x. Okay, the next thing I'm going to do here is, so we have something that is common from the numerator, which is cos 2x. So if I take out this cos 2x, I will leave negative in the bracket, then it's going to remain negative sine x. Okay, or yeah, so it's going to remain negative sine x, and y for the second one, so it's going to remain negative cos x, and everything divided by while for this one we have sine square x minus cos square x. But our aim is to prove that everything equals to sine x plus cos x. And if I take out negative out of this, from this numerator, if I take out negative and I interchange the denominator, I will let cos square start. Here we are going to have cos 2x, then bracket. So here becomes sine x plus cos x. Everything divided by, so by interchanging this as well, negative cos square x will start, and we are going to take out negative, then we have cos square x minus sine square x. All right, so negative will cancel negative from numerator and denominator, and we must know that this cos 2x is one of the identity, which is equivalent to cos square x minus sine square x. So these two will cancelled, and here comes to what we're asked to prove, sine x plus cos x. So this is how to prove it. I hope you like the steps I take in proving this theorem. Thanks for watching. Don't forget the steps I used. Subscribe to this channel and like this video. I will see you in the next class. Never stop learning.